Welcome everyone. I'm gonna start. There's still people coming, but I'll start so we are punctual. I don't know if it's your first time in a Rhino user webinar, but welcome to a new session. So we have the pleasure today to have Aman Agrawal. Welcome.
Thank you.
My name is Maria Agustina Jaime, or Agustina Jaime. I'm from McNeil, Europe. I'm an industrial designer myself, so I'm very excited about this webinar. So I'm gonna present Aman with a lot of pleasure. He's an industrial designer as well, specializing in creating complex 3D surface models and parametric textures for manufacturing. So he has provided consultancy to industry leaders such as Design Partners, VSH, and Hamilton Beach. So Aman shares his extensive knowledge and practical experience with hundreds of design students and professionals worldwide through engaging live classes at academy.xyz. So feel free to use the chat. As I said, we close the mics and the videos to not interrupt Aman. So any question that I can answer, I will answer it through the chat. If not, we leave around 15 minutes at the end while I will read the questions and Aman will answer them. Don't worry that this webinar is recorded. We will put it in our YouTube channel. And I will send an email to everyone that participated with the special links and the recording. So welcome, Aman. Thank you so much for sharing your time with us and your knowledge. So whenever you're ready, you can start. And thank you everyone for participating.
Thank you. Thanks for the very kind introduction. And welcome everybody. I can already see some familiar faces that I might have interacted in my online classes or over LinkedIn or Instagram. So welcome everyone. I'll first start by confirming if you all can hear me properly, if you can see the screen. I hope you all can see the screen. Can you see the color change? Okay, perfect. All right, appreciate it. All right, so we'll just go right through it. And then at the end, we will have some time and we will take some questions and answers. That's the more fun part. So let me explain you the format of the webinar. So I'll first start by explaining you a workflow of a project that I have worked on, like a product that is in the market, and how I have used Rhino and Grasshopper to create that product. And after that, we will create a demo project. So you will learn how to create a model in Rhino, then how can you apply a texture on a part of it in Grasshopper. And after that, we will take questions and answers. Okay. So Augustin already did a good job of introducing me. So I'm Aman, I'm from India. I've been living in Spain for the past 10 years. And for the past 6 years and 6 years or 7 years, I've been using Rhino and Grasshopper as my primary CAD tool. And I have done some freelance projects. I have done some commission projects. And what I have learned during doing these projects, I kind of packet it into courses and that we offer on our live academy for you and your team at Academy. I have co-founded this academy with my colleague Estela, where we offer training for Rhino and Grasshopper to industrial designers. These trainings are live and you have the opportunity to interact with me in real time, clear your questions. I'll talk about it later on. You can follow us on these social media handles, and you can ask any questions related to Rhino and Grasshopper. So feel free to drop us a message over these two Instagram handles. We also are on LinkedIn. Just search for our name and you will find us. Okay. Now, before we get started, please go ahead to this link. Let me copy and paste the link to the chat. This will take you to the article, this one, okay? And you can click on the download folder. That is going to take you to a Google Drive folder. And you can download these files, okay, the Rhino and the Grasshopper file for your reference. Okay, I'll explain you one more time how to access these links. Now, let me quickly take you through a project that I have worked on in the past using Rhino and Grasshopper. And then we will do the project of the electrical appliance. So this project was commissioned to create a texture on the handle part that was later on being manufactured. So the client supplied us with the step poly surface. So that means the model was actually not made in Rhino. It was made in CATIA, if I remember correctly. They also provided us some basic details like the file tolerance that they were assembling. Everything was at 100th or 1000th of a millimeter. In this case, it was 100th. And the geometry that I received was a solid poly surface. So you import it as a step file in Rhino. Now, I can also give you some suggestions if you are going to do a similar project in future. So be sure to request the correct type of file format. So don't request STL file. If they can provide you step file or IGES file, which is ideal to work in the NURBS context. So always request that. Make sure to define the parameters properly with your clients. So in this case, we had to create a texture that has a specific dimension, more or less. And we also were provided with a set of rules that we needed to follow in order to make sure that we were on the same page. Then I started working on it. So this texture was basically made using Kangaroo. So you use Kangaroo as a particle simulation. And a lot of people might think Kangaroo as like an experimental tool, or maybe a tool that is used by structural engineers or architects. But in this case, I used Kangaroo for form finding, kind of like a draping texture on top of this poly surface. There were also some rules that I needed to kind of take into consideration. So they provided me with a region where the parting line was supposed to be. And I had to make sure that the texture was actually aligning in that portion. So that was probably the most difficult part because I had to anchor some points in Kangaroo. But eventually it turned out to be pretty decent texture. They liked the end result. Of course, we had some warping going on. And this is like the bottom part where the most warping was happening because the top part was basically a cylinder. And these colorful triangles that you see, this is done using the Lunchbox machine learning plugin, okay? Because there were certain triangles that were too stretched or too small. And I kind of needed to group them together so that I can resolve those issues, okay? So using machine learning, I was easily able to detect all of these triangles and cluster them. And later on, I was able to correct the issues, okay? So always remember to kind of like fine tune these minor details, even though it's not asked, but yeah, you know, you had a bit of extra effort to it. It does look better at the end. Also evaluate the design for manufacturing criteria. So make sure that the parting line were aligned properly. As you can see here, it's exactly falling between. You might also have to do some manual calibration. It's not going to always come out exactly as you want from Grasshopper. And you can export multiple versions and share this with your client. Okay. In this case, you know, we offsetted the triangle slightly only on those portions where we had a lot of stretching going on. And eventually we transferred the texture to the original poly surface. And that was the end result. Again, this part was later on exported to the other CAD packages step file. And that was integrated back into the final assembly for design for manufacturing. Okay. So this is like a workflow where we start from importing step file in Rhino, cleaning it up, orienting it properly, applying texture in Grasshopper, baking it back into Rhino, transferring the texture, exporting it back as a step file, and integrating back to the final assembly. Okay, so this is a very practical use case scenario of Grasshopper. Now, we will be starting with the exercise. So for that, let me take you through the web page. If you are not able to download the files, please go to our webpage, academy.xyz. You can head to Resource Learn. And then you will find this first article. And here you will find the download files. Okay, I hope you all were able to download the files. If not, I will also upload the files in the chat just in case. Okay, I'm uploading the Rhino file first. Let me see, probably let's see if I can upload the file. Just give me a second. Yeah, I think I'm not able to upload the file because it's disabled in Zoom. But I hope you all are able to download the files by following the link. Were you all able to download the files? Shall we get started? Perfect. Yeah, in the link that I have provided, you can also find a step-by-step construction of the model. But of course, don't worry, we will go through it. This is just for latter part. If you're trying to follow along, watching the recordings, you also have a textual description of the steps that we will be taking. Okay. I have also attached some very interesting sublinks. So there is one link from Alias, which is the 10 golden rules. I highly recommend you all to read through these rules because it's applicable no matter which CAD software you use, as long as it's a NURBS CAD software. Okay, perfect. So with that said, let's get started. So what we will do in this exercise is we will start by creating the hand blender. And in order to create the hand blender, we will start with a set of curves in the U direction. We will create cross-section curves using these U curves. And then we will generate additional curves like for the bottom part, maybe the cable as well, and the cutout parts here as well as here. Okay. And finally, we will stitch it as a surface and apply the solid modeling technique. All right. And at the end, we will isolate a part and we will use Grasshopper to apply like a cylindrical pattern on top of it. All right. So with that said, let's open the file to take a step-by-step follow-up of this process. So let's open Rhino. And this is the download folder. Okay, so let me drag and drop this Rhino file in Rhino. Let's open the file. Okay. I have exported the file for Rhino 6 and beyond. So if you are using Rhino 6, 7, 8, you should be able to open the file. Let me know in case you're not able to open. Okay. If you're not able to find the download link, let me also share you the download link. Just give me a second. All right, there you go. I have pasted the download link as well. Perfect. So let's get started with the exercise. So I will just first explain you what is the topology that we are trying to aim for, because the complex part is the top part. The remaining are just simple either revolution operations or Boolean operations. So that's easy to do. So the main body of the hand blender is made using surface from a network of curves. Okay. So let me first explain you simply what is a surface topology in any NURBS CAD package. So a surface is basically a rectangular fabric. I hope you can see it. Let me go a bit far away. Okay, it's a rectangular fabric that has 4 sides. Okay. Then what we will do is we will convert it into a cylinder. Can you see how I'm able to convert it into a cylinder? By joining this edge and this edge together. Now this rectangular fabric can be stretched in different manners. You can stretch it as you wish. You can fold it in different manners. Okay. Now this rectangular surface is made out of fibers. Okay, fibers. Let me take out another prop. Okay, fibers. So these are the fibers, threads on that fabric, which goes in one direction, which is the U direction, and the V direction, the opposite direction. Okay, just keep that in mind. So rather than generating the surface in its final form, what we will do in this exercise is we will create these U and V curves. And then using these curves, we will stitch back the surface. Okay, let me show you the topology of the surface. And then we will start with the exercise. So I will create cylinder. Okay, you don't need to do this part, just to explain you the topology. Okay, let me just add a couple of control points. And you first understood how I made from a rectangular surface to a cylindrical surface. So this is the cylindrical surface. I will take the top edge of that cylinder, okay, and I will shrink it to 0 units. Okay, the top edge, we will shrink it to 0 units, and it's going to look something like that. And that is basically the topology we are aiming for. Again, the rest is just positioning these points in correct location. Okay, but I hope you understand what topology we are aiming for to create the blender. Okay. All right. So with that said, let's get started with the exercise. Okay. And you can see here in the final position of the surface, all of these red and green curves, these are the curves we will manually make and then convert it into a surface so that we have more control. Okay, perfect. So once you have opened the file, you can head to the layers in Rhino. And as always, we make like a step-by-step construction of the geometry. So you can just unblock the layer and follow it along with me. Perfect. So the first step is to create a curve from the right viewport. Just a second. Yeah, I think I cannot draw on top. No worries. So it's basically creating a curve from the right viewport. Starting from here, let me just turn on object snaps. Okay, starting from here till here. Okay, so I have made these curves. So what we will do is go to our right viewport and let's use curve through control points. And we need a curve of degree 3. It doesn't make sense to use a curve of degree 3 or higher, because later on, as we will be constructing the surface from network of curves, the command will only generate surface of degree 3. So even if you use, let's say, degree 7 single span curve, in that particular command, it doesn't make sense, because at the end, you will be rebuilding a surface using a degree 3 surface. Okay, so we will start with degree 3, and let's start by clicking here. And I'll add a couple of points. Okay. The goal is to use the least number of points possible. Also try to keep the distance between the points in a predictable manner. And the last point is going to be at the end here. Okay. I can hear some of you are saying that, are you having audio issues? No. Okay. So once you have made that curve, okay, we need to figure out if this curve is of good quality. All right. And you can do that using a very interesting tool that you can find in Analysis tab. Okay, you can find it here or here, Analyze, Curves, Curvature Graph On, or here, Analysis, Curvature Graph. Select the curve and press Enter. Okay, so it's going to pop up this window, which is going to give you a description of the curvature of the curve using these graphs, kind of like a roller coaster ride. Okay, you can change the density of these tracks or graph, change the scale. Okay. All right. So, so you have to move these points in a way where you are maintaining constantly positive curvature. Positive curvature means that these tracks, they should always be on the outside. The moment you see something like this, it means that the curve is bending inwards. So later on, when you create these curves as a surface, the surface will also reflect the light in that particular manner. Okay, so make sure to keep positive curvature. You have to slowly sculpt the shape. Take your time. Some of you probably don't know, but in Rhino, we have a very interesting tool for moving the control points. Okay. For example, if I'm doing very minor calibrations here, the force of the gumball is at the moment 100%. So there is a command called drag strength. Drag strength. Okay, so when you select a point, you can change the drag strength from 100 to some other number. So for example, if it's 100, for the amount you see on the screen is the amount that the point will move. But if I reduce the strength to, let's say 1, if I move the same amount of distance, the point will move by 1/100th of that distance. So this is very good for very fine-tuned calibration. Okay, you can move these points slowly, see how the curvature is deforming, and calibrate the shape. Okay, you can change the drag strength. All right, so with that said, you can delete this curve or you can keep it, because in the next layer, calibrate, I have already made that curve. Okay, you can see that curve. Okay, I've already made it. So you can use that for the next step, which is going to be creating the curve in the backside. So for the curve in the backside, in a similar manner, you will start by drawing the curve. You will move the control point slowly and capture that shape. So if you unlock the next layer, I have also made that. Okay. All right. Now, very important thing to keep in mind, at the anchor point where the two curves are connecting together, you need to make sure that these two curves are at least tangentially continuous. Okay, so if these 2 points are somewhere else, we will have like a sharp corner, but we do want a smooth corner as we will convert into surface. So we will achieve that if we are able to keep these 2 curves tangent to each other. There are 2 ways we can do it. One is by using the match command. So let's say if this curve was not tangential, I will run the match command. Okay, I will also show you in the help menu how that command, let me rerun it. Okay, yeah, here, match. And if you scroll down, you can see how this command can be used. Okay, so you can click on the curve that you would like to match. And I have created an assisting curve, the purple curve. So you can go for tangency. And then if this was not in place, you could have used the same command to match this to that, tangency. Okay, so this way we have these 2 curves tangent to each other. All right, let's go back to layers. Yes, we will take the questions just in a moment. All right, so the next part is generating the curve in the center. Okay, the parting line. Well, more than parting line, this is going to be used to create the cross section of the surface. So let me show you a very neat trick that you can do in this case to create that curve in the center. Okay, rather than starting from scratch, you can use a command called tween curves, which will create a curve in between of these 2 curves. Okay, you can change the number of output You might have 10, 15, whatever. You can change the output to 1, and it's going to give you a curve exactly in the center. Okay, now you can use this as a base, and then you can fine tune it just like other curves. All right, so let me unlock the next layer. So this is the curve for the tween command. If you go to now perspective mode, okay, you can use this curve from the front viewport to draw the cross section. Okay, so you select the curve from the front viewport. Let's select these points and move them to the right direction. Okay, so we have defined the shape of the curve from the right side. Now it's time to define it from the front side. Okay, so you can move these points as per requirement. You also have to make sure that we maintain tangential continuity, just like as I showed you earlier with that line. So you can run the command match to match this to that. Okay. And now you can further calibrate it. So I have already made this curve for you. If you unlock the next layer, curve front. Just like before, use your curvature graph to see the shape of the curvature. Okay. Perfect. So now let me go back to perspective mode. Okay. This was just to show you a step-by-step construction of the curves. So what I will ask you to do is go to layer 6. Okay. And unhide it. Now hide every other layer. Okay, because I have already made these 4 curves, which are our U curves in one direction. Okay, now we will use these curves for the next step. So I will recommend you all to hide the other layers. You can take your time later on, create your curves from scratch. Okay, let's see what are the next steps using the curves that is in the 6th layer. All right. All right, so the next step is to create the cross-section profile. So basically what we are trying to do is generate a curve that is going to define the shape in this direction. Okay, now I can manually make it, but you can see it's not clean, it's not symmetrical, it's not planar, which will later on impact the flow of the ISO curves when I run the surface from network of curve command. Okay. All right. So in order to do that, what we will need is a set of cross sections like this. Okay. Whichever place you would like to define the cross section profile, just draw a line from the right viewport. Something like this. Okay. So I have already made these lines for you. Let me delete these curves and unlock the 7th layer, CSEC, cross section. Okay, so make sure you hide every other layer except 6th and 7th. Now, let me show you how can you generate the cross-section profile. So there is a command in Rhino. Go to Curve Tools. And here you will find a command called Curve from Cross-Section Profiles. Okay, you can do this with me. Go to this command. And what it is asking you to provide is a set of curves in order. So basically, do you want to select the curves in clockwise or counterclockwise direction? That is how it's going to create that curve. You don't have to worry about which curve you start with. Just select any curve. Let's say I select this one. Now the next option is either the curve on the right side or the curve on the left side. I cannot select the curve which is in front this curve I cannot select. Okay, so let's say if I select the one on the right side, which means I have to select the curve next to it, which means I have to select the curve next to it. Okay, can you see I selected the curves either in the clockwise direction or counterclockwise direction. Okay, so once you have selected these curves in order, press enter. Now it's asking us to select the cross-section line. Okay, we have to draw the lines. In order to do that, just go to the right viewport and use these lines that I have provided you as an assisting line. So the moment I draw this line, you will notice I have made that cross-section profile. Again, okay, again, and again, and lastly here. So if you go to the perspective mode, you will notice we made these curves using that cross-section curve from cross-section command. I hope you were able to try it out. Let me repeat. Curve from cross-section of profiles. Select the curves in ascending, clockwise or counterclockwise direction. Press OK. From the right viewport, we will add some lines at these locations. And it's gonna kind of like chop these 4 curves, creating those cross-section profiles. Okay. For the bottom 2 or 3 profiles, we will probably use the circle command. So in circle command, you have circle from 2 lines, 2 points. This is just to ensure we have more like a cylindrical cross-section towards the end. All right. So these are the final set of curves, and you can unlock the next layer, V curves. Okay, and let's unlock the 9th layer and hide everything else. Okay, make sure to hide every other layer. Okay. Also, I think it's better you make this layer active and hide even the start layer if you have generated the curves to not create duplicate curves in that location. All right, so these are the final set of curves. Okay, make sure you make this active, hide everything else. So now we will convert these curves into surfaces. So let's go to Surface Creation tool. And then the command is surface from a network of curves. Okay, so when you run the command and select the curves, it doesn't matter the order, you can just select all the curves. Make sure you have hidden everything else, or else you might be selecting some curves like the assisting curves or duplicate curves, and it might give you an error. Now, once you run the command, what this command does is it creates a degree 3 surface, and the surface is trying to use these input curves that we have made as an approximation. Okay. And the approximation is how far the surface can be to the input curve. Okay, so let's say you want the surface to be very accurate to the input curve. You can reduce the gap 1 millimeter. Okay, maybe even smaller, 0.1 millimeter. Okay, so the smaller amount I put, the closer that surface will be to the original set of curves. However, here we are running into a trade-off, because when we are trying to achieve accuracy in terms of using the input curve, we are generating a lot of spans, a lot of control points. Now, this surface will be very difficult to manually manipulate later on. Okay, so I will recommend you to use a tolerance of maybe 1 or 2 millimeters, so that it creates a very simple surface, as you can see here. I'm also going to be choosing a loose option rather than trying to force it to these input curves in position continuity. Okay. This is because you can see now the complexity of the surface is very simple. Okay, we are able to manually move these points and sculpt the surface furthermore. So you can now redo the steps. If you don't like certain parts, you can turn on the control points and further calibrate it as per your requirement. Okay, now the output that you see is the final output now. Okay, so whatever modifications you do here will be set for your final design intent. All right, so if you unlock the next layer, that's the final surface. I have already made it for you. Make sure to always hide the previous layers or else you will get confused. Okay, now it's time to separate the bottom mechanism from the main part. So let's unlock the next layer. And what I have done is I have created two sets of curves, one by defining the original size and then offsetting it slightly for the coupling mechanism tolerance. And I'm also creating a line here to create that chamfered part. All of this will be revolved using this line, which is going to be the central axis. Okay, so I've already done it here. And you can try this with me. Okay, run the surface creation revolve command and select the curves, press enter, select the axis. The length of the axis is not important. And then you can click and define how much you would like to rotate, or let me rerun the command. You can just press enter and enter. That is automatically gonna revolve at 360 degrees. Let me repeat, revolve curve profile. Start of the axis, end of the axis. There's also this button you can press, full circle. Okay, so let's unlock the next layer. I have already done that for you. And let's unlock the next layer as well, where I'll show you how can you intersect these models. Okay, so I'm moving these geometries by a fixed amount. If some of you have already done our webinar, you know the drill. It's 150, 200 units in this case to overlap it exactly in the spot. Okay, so each geometry is moved by 150 units afterwards, as you can see. So you can work on it and then move it by 150 and work on the second part. So let's see how can we separate the two sections. We will be running Boolean split command. Boolean split. Okay. So let me run Boolean split, select the geometry, use this, and this is gonna trim out the bottom part. Okay. So this is the top section. And I have created another copy of the same model with the same revolved profiles. No, we didn't activate history. All right, so now I'm going to separate the bottom section. So Boolean split this one with the bottom cut out. So let me delete the top part. We don't need this. And lastly, we need to also do Boolean split with this part. We don't need this. Okay, so as you can see, we have the top solid and the bottom solid. In case you're wondering, how did I make a solid model? It's very simple. Run the cap command. Okay, cap, to convert it into solid geometry. And you will also notice that in my case, I see these green and red curves, which are the UNV curves. In your case, it might be different color, maybe black color. So here onwards, it doesn't make sense to visualize these. So you can select the models, and in the properties tab at the very end, you will see an option called ISO curve density, and you can hide it. Okay. This is also one of the reasons models made in Fusion SolidWorks at least on the screen, looks cleaner because by default, some of these CAD packages, they don't show you the ISO curves, which in Rhino, by default, you see them. And that is why sometimes people have the notion that you don't make clean models in Rhino, okay? The model is clean, it's useful. It's just that we are visualizing all the ISO curves, okay? So that is the final assembly. If you want, you can also apply a fillet between the two parts. Okay, let me zoom in here. And you can run fillet, maybe 0.5, something like that. Okay, perfect. So that is the final output. Now let's go back to layers. Now I'll show you how can you create the cutout for the front part, the button interface. Make sure to hide everything else. Okay. If you hide everything else except the 14th layer, make it active, you will notice that I have made a curve at 0, 0, 0 from the right viewport. Okay, and that curve will be used to create that cutout section. How did I calibrate that curve easily? It's because I used the record history function before I projected from the right viewport, project that curve to this surface. So when you record history, what happens is the moment you modify any of these position of the curve, this automatically updates. Okay, you could also move it back by, I think, 900 units. 50 more, yeah, 950. So this way you can see in real time how these two curves are creating that shape. So in the right viewport, you can modify not this one, but the curve that we projected and how it's affecting the shape in 3D from the front viewport. Okay, so with that, you're able to match the image. Okay, all right, let me undo the steps. Let's unlock the next layer. So I've already created that surface for you. And you can run Boolean difference or Boolean split to separate the front part. Okay. Lastly, let's unlock the button layer. So for buttons, you create curves. Then you move the or offset the curve slightly to create the hole and then the buttons separately. Okay. So the first step is to project the curve. Project the curve to the geometry. In the perspective mode, it's going to project in the z-axis. So you have to be in the correct viewport. So once you run the command, go to the front viewport and project. Okay, there we go. We don't need the intersection, so you can split the curves or trim the curves access parts. Okay, so that is the cutout shape. Okay, that we will split from the model and we will use it to perform Boolean difference to cut out the hole. Okay, that is for the cutout part. Now for the buttons itself, what I will do is I will create the offset and let me trim the access part. So the button is going to be complete in the bottom section, and in the top section, it's going to be the parts here that you see. I think I deleted the correct ones. Yeah. So now we can project these curves to that surface. Okay, that is going to give us these two curves projected on the surface, which we can use to split out the buttons. Okay, so that's what I have done here. We have the buttons, we have the solid, and then you will perform. Let me show you. By moving the buttons separate. And this is 100, 200, 300. So let me move it by 300. Boolean difference. And we have the cutout shape. Then you have the buttons in its place. And you can apply fillets here. Okay, so let's unlock the next layer. So in the next layer, you will see how can we make the structure hollow, okay? Because at the moment it's a solid geometry. In order to include any electronical parts inside, we need to just create a thin skin. So you can go to Solid Tools, Shell, define the thickness, let's say 1 millimeter, and then press OK. So when you run the command, you have to select the face or faces you would like to remove. Let's say I would like to remove this, this, and this face. You can see it leaves a small thin wall while deleting those 3 faces. Okay, so similarly here, the shell command, I want to delete that face and leave a 1 millimeter thin wall. Okay, I have taken the same curve that I found there. This curve can also be generated, not like manually making it, but maybe using something like a draft angle analysis in Rhino, which lets you evaluate the demolding angle. And in this case, I think if I rotate it slightly, I can get a better demolding angle. So maybe 55 degrees, negative 55. Sorry, positive 55. There we go. Okay. So you can define the draft angle depending upon the material and if you have any texture on top. And this is going to give you the parting section, which you can generate using these 3 options. Anyways, these are a bit advanced operations, but I'm just showing you that rather than creating these parting lines manually, we also have design for manufacturing tools in Rhino that can assist us in creating these parting lines. So I will just offset that curve, okay, by giving a bit of tolerance of maybe 0.25 millimeters. And using that, we can split the solid using this and split the other solid using this. So this is going to leave a small fragment in the center. That's the tolerance part. And then we will break it into 2 pieces, 2 solids, as you can see. Okay, you can apply then any kind of fillet if you want on the model. Okay, you can also apply a fillet on the parting line. And this is the final assembly. Okay, lastly, let's open the next layer. This is for generating the bottom part of the mechanism. So in the front viewport, I made these curves, okay, using this as a reference image. Of course, I had like moved it down and then moved it up to its current position. And we have a cross section, we have the axis. We also have these curves, which you will be using for creating these vents for the liquid circulation. So that's what you see here. Just like before, surface creation tool, revolve. This is the axis, full circle. Okay, I'm using these circles to extrude them symmetrically. In Rhino 8, you can actually use Shift key to symmetrically extrude using the gumball. And then you can create a copy 90 degrees, Boolean difference to remove the 2 parts. You can also apply fillets. think it's a bit more, maybe 20 units. Okay, just to clean out the corners. All right, so I have already done that here. And then we also had these other shapes that we will do the same with, extrude, and then Boolean difference. Okay, and lastly, like every time, you don't need to see the ISO curves, so you can go to properties and hide the ISO curves. All right, I've also positioned the geometry from here. Can you see the advantage of modeling the geometry by a fixed distance? This is kind of like a physical timeline, and I can easily move this geometry to any of these other places by 150 units. Okay, so it's very easy to assemble the part at the end. Let's go to layers, unlock the second last layer for generating the blade mechanism. So it's basically creating a set of curves, intersecting the curves, converting these into surfaces, extruding them, and converting them into solids. In order to create the opposite side, like the blade on the other side, because the blade is, you cannot just mirror it because the blade is looking upwards. So you first mirror it on this side. Okay. And then you rotate it by, oops, I think you mirror it on this side, and then you rotate it by 90 degrees, 180 degrees, sorry. And then you can move it to the corresponding place. This way you have the correct orientation of the blade. Revolve, some additional extrusions, and that's the final output. Okay. So the very last step is to take this solid, okay, which you will find here, and we will explode the solid to isolate just the outer skin because we will be applying a texture there, and we will join back everything together. Okay, so in order to apply the texture, we will be using Grasshopper. So let me show you quickly how can you create a simple texture on this part using Grasshopper. So the first step is to launch Grasshopper, and you can do that by either clicking this button, Launch Grasshopper, or run the command Grasshopper. It's going to take a couple of seconds. I've already launched it because I have a lot of plugins, and sometimes it takes quite a long minutes to open the interface. Now, once you run Grasshopper, it's going to pop up this window, and here you will find these different modules that we can connect and create like a automation pipeline or parametric modeling workflow and visualize it in Rhino. Okay. The general way you use it is you dock the interface on the right-hand side. Okay. Now, the first thing you might see, people who are opening Grasshopper for the first time, is that you have less components than I do. Okay. That is because there is a setting here called obscure components, which you might have turned off. Okay, by default, it's turned off. So if you haven't changed it, you can change it and see more components in the panel. Okay, so let me dock this on the right-hand side. And we will now apply a texture on this part. Now, I could technically model this part from scratch in Grasshopper, but imagine if this part was even more complex. You had some kind of deformation to it, some kind of cut to it. So creating the model from scratch in Grasshopper will take quite a long time. So what we can do is we can directly reference this model inside Grasshopper. Okay, so let me show you how. So the first thing you need to do is go to the very first tab, the very first sub-tab, and here you will see a command called surface. Let's click and drop that object here. So it's a container where I can store a surface geometry. Okay, so let's right click on it. And there's an option called set one surface. This way I can import that surface from Rhino to Grasshopper. Okay, were you able to test it out? Were you able to launch Grasshopper, everyone? Okay, perfect. So after that, we will be using a command from the Surface tab, Utilities, called Surface Frames. There's another way you can find these commands. Just look at the name that you see on the top of the icon. I'm using a plugin, that is why you can see that name. If you don't see it, no worries. Just double click anywhere on the canvas and look for a command called Surface Frames. It's going to look like a rectangle with 6 smaller planes. Let's connect it here. And this is going to populate the surface with perpendicular frames. It's very important in Grasshopper that we hide the previous steps. And you do that by selecting the surface or whichever node you want to hide. Middle mouse button, hide. Okay. In order to change the number of frames in U and V direction, just double click and write, let's say 25. So you will have 25 frames in U, and let me write the same, maybe 150 in the V direction. Okay, be careful because if you set a very big number, it might even crash your Grasshopper environment. So you decide how many frames, how many textures you want. I will recommend you to start with something low, and then you can increase the number later on. Okay. Once you have these frames, you can create cylinders on these frames. So let's write cylinder. We will be creating cylinder on these base of the frames. You can hide the frame. Again, middle mouse button, hide. And you can define the radius. Let's say you're going to set the radius to 1.25 millimeters. So you can change the radius of the cylinders. And you can change the length of the cylinders. Okay. You can also change the number of items. Be careful because if you overdo it, it might crash Grasshopper. All right, so once you have defined the radius and the length of these cylinders, you can convert them into solid shapes because at the moment they are open geometry. So you can run a command called cap, just like in Rhino. Okay, and these are gonna create your capped textures. And finally, it's time to convert these textures into a geometry in Rhino. And you do that by running a command called bake. Okay, so you right click on the cap hole. You will see an option called bake. And let's bake it, let's say in the start layer or maybe the Grasshopper layer. Group yes, please, and press OK. So this is going to convert those phantom geometry in Grasshopper to real geometry in Rhino. Let me repeat, right click, bake. Layer, group yes, please, because we are baking a lot of items. It's easy to select afterwards. Right, so I have made a more advanced version of the script. If you go to the download folder and just drag and drop this Grasshopper file here, you can see the end result. And I've also mentioned you step-by-step construction. In this one, I have made it in a way so that it intersects with the model. So you can maybe do Boolean union and Boolean difference afterwards. And I have made another version of it where you can actually turn this on, turn this off. Okay, where you can also fade the texture based upon an attractor workflow. So let's say I would like to use this line Let me set it here. And based upon the distance from the line, these circles will change their amount, okay, their radius. You can control it here. Okay, so you can later on take your time and review these models. All right, so once we are done with everything, let me unlock the last layer called the final assembly. So it's made by moving all of these parts. Let me move it by 600, 600, 600. Okay, this is also moved by 150. Join everything together. You can move these by 600, 600, this by 50, right? So you can see we are able to assemble the parts by moving them with a fixed amount of distance. Okay, and for the cable, it's just you have to go to the right viewport, draw a curve, and then pipe it. So that is the end result. Okay, I hope you were able to check out the steps one by one. You can take your time, review the files properly. Okay, and go through the steps one by one. Okay, we are running out of time, so let me just explain you a couple of more things and we can take questions. All right. So, all right. So I hope you were able to follow through. If not, you can watch the recordings and practice it on your own. Now, once you make your own designs, you can create your own variations. Maybe you can apply textures on different parts. We highly recommend you to share on your social media and tag us, and we will also share it with our design community. Okay. Let me explain you one more project, a couple of things about Cademy, and then we will take the questions and answers. So this is another project where I helped the design team from BSH to generate a texture on one of their top loader washing machines scrub tray. So basically in India, they use a lot of top loader washing machine, and this kind of plastic part, it has a texture which you will use to scrub any stains. Okay, and the part needed to be kind of made with this fading effect on the boundary. Okay, maybe G1 or G2 fading effect, and it had these sharp corners which you will use to scrub the part. Okay, so we ideated a couple of ideas. We prototyped it in Grasshopper, and it was basically made in Grasshopper, the most of it, and then some operations were also done in Rhino to clean and properly place the part, the texture on the final solid model. Okay, so here's another example of using Rhino and Grasshopper to create textures. Right, so apart from that, let me quickly take you through to what you can learn from us. So at Cademy, we offer 5 different types of courses, okay, which are offered on the weekends, Saturday and Sunday, which is not going to interrupt your studies or your professional work. 3 of these courses, the Rhino Masterclass, the Grasshopper Masterclass, and the Keyshot Masterclass, are our foundation courses, and they are ideal for beginners and intermediate users. Then we have 2 advanced workshops. So we have the Advanced Parametric Texture course and the Computational Design workshop, which are ideal for intermediate and advanced users. Okay, you do need previous experience in Grasshopper in order to join either of these workshops. Right? We also offer training for companies. So if you're working in a company and you want to learn during the weekdays on your office hours, and you would like to cater to specific bespoke training, we can prepare a personalized curriculum to resolve specific questions or workflows, and we can then tailor the training as per your requirement. Okay. You can also check the projects that our students have made on our webpage. So you can go to our portfolio section. And these are the projects that our students have made after doing, let's say, the Rhino Masterclass. We request our students to create these projects so that they have a constant contact with the software. They also request certificate after submitting these projects. Again, it helps them keep on practicing. We also have an online community where they can share their doubts, and together we can resolve their questions. Okay, so you can also check those. You can also check our additional learning resources like our webinars. So these are our free webinars that you can find in our webpage. I'll show you just in a moment. And they are a very good resource for you to start learning Rhino, Grasshopper, and Keyshot if you want. And they are also a way you can see our teaching methodology, how we teach these softwares. So you can find these webinars on our webpage here. Again, you can download these resource files. The stream of all of these webinars can be found in our YouTube channel. Okay, so let's say you would like to learn how to model this Harman Kardon speaker. You start with first modeling it in Rhino. And you can see, like, every time we have a step-by-step construction, so you know what to take, what's the next step to take in order to model this geometry. We also followed through with a texture process in Grasshopper. Okay. And finally, you will transfer the texture to the polysurface part. And later on, if you want, you can render your concepts, your design for your portfolio, for your website, for your clients in Keyshot. All right. So these webinars can be found here. Let me copy and paste you the link. Okay. And we also have additional learning resources like how to create polysurface texture in Rhino and Grasshopper. You can download the Stemple files, or how to create a bottle and apply texture using Lunchbox and Grasshopper. Okay. Lastly, you can find the dates for our upcoming courses on our calendar page. Okay. So you can see the next date. You can also check the time zone. So if you're in Asia, Europe, you can choose these options. And if you're in Europe and United States, you can choose these options. Okay. So with that said, we're going to conclude here. Let me know if any one of you have any questions.
I have a couple of questions that I wrote down. I don't know if you're gonna, I haven't quite read them, some of them, but I don't know if we're gonna have time to answer them all. But I just want to clarify, as said before, this is recorded, so we're gonna upload it on our YouTube channel. So if the question is about repeating any steps, you can watch as many times as you want in a couple of days when I will upload it. And if not, clearly on the website of Codemy, you have amazing resources to repeat any of these steps of Grasshopper or any detail that you want to expand, or any information that you want to expand. So saying that, thank you so much, Aman. It was very interesting.
Appreciate it. Thanks.
Even more because I know that Grasshopper can be a little bit intimidating for some industrial designers when it's when it's a little bit different on the workflow of Rhino. So, but I think it's amazing to see that it doesn't have to be so complicated, and that it can take you to a lot of places, and you can expand all your possibilities more, even in product. So thank you. So I have sorry.
Yeah, no, go ahead. Yeah, I'm just reading through the questions as you were mentioning. Yeah,
there are a couple that let's hopefully answer them all. So I have first saying the curve comms should be in positive direction. It's clear. How important to keep those comms pretty? Does it influence the quality of the curve?
Sure. So basically, whenever you create a curve in any NURBS CAD package, you select a degree. Okay, the degree can go from 1 to 11. It has a more complex explanation, but let me just simplify it. And whatever the degree is, you just add one more to it. So let's say the degree 3 plus 1, 4. So until I create the fourth point, I'm creating a single span curve. These spans are basically, you can think of it like a wooden stick. Let me span wooden stick. Let's see if I can quickly find a reference image. NURBS. Just give me a second. Yeah. Span wooden. Yeah, I'm not able to find it right away, but they are used in shipbuilding hull. Let's see if I can find now. Yeah, here I have it. Okay, so you can think of these spans literally like these wooden sticks. Okay, so whatever the degrees plus 1, that's the like a single wooden stick. And if I show you the curvature graph, again, it's very pretty. It's very smooth. Okay, because it's made out of a single polynomial, single mathematical expression. What happens is the moment you create more than 4, you will add another span next to it, which you can see here. Okay. Now, I don't know if you know about the curvature continuity criterias, but degree 3 curve, this is the reason we use a degree 3 curve, because within spans, we already have curvature continuity. So no matter if you use multi-span curves, the curve will be internally curvature continuous. You won't notice any sharp highlights when you manufacture the part at the end of the day. You can also test this out using a command called emap in Rhino. Emap, environment map, how that geometry is creating a high quality surface. Okay, the curve is creating high quality surface. Now, in order to keep this pretty, like, you just have to make sure that it has a nice flow. The ramps, they are as smooth as possible. There is nothing wrong in having a ramp like this, okay, the curvature graph like this. You can also use a command, I don't know if you know about it, called fair. It only works with degree 3 curve. So let me show you this thing. So run a command called fair, and just keep on running it multiple times. You will notice that the curve will automatically smooth out. Okay, so you can use this command to assist you smoothing out the curve, fairing the curve. All right, more questions.
I have another question from Mike. How do you add a draft to the buttons?
To the buttons, sure. So if you go to the button layer, and we have the buttons here. So let's say in this one, or even the cutout piece, let's say this one. In Rhino, when you are trying to extrude, by default, it's going to be extruding without any draft angle. Okay. But if you go to Solid Tools, Surface Tools, and here you will find Extrude Surface Tapered. And you, of course, have to define the direction. In this case, it's going to be this direction. And then you also define what is the draft angle. So let me show you from the top viewport. We are able to define the draft angle. You can change, let's say it's 10 degrees. Okay, or you can change it to, let's say, -10 degrees. Okay, and once you have that as a solid, you can perform Boolean difference, and then you can join it. in the command direction. Okay, and then you can finalize the cut. Question.
Perfect. Thank you. Trying to answer the ones that at least I can. I have another question from Sanya. Is shell surface similar to offset surface? I saw that someone kind of asked it, but I wanted to leave it to you.
Sure. They do similar things, but the shell command, which is in the solid context, this is ideal for primitive shapes, okay, or very simple shapes. This was very simple shape, to be honest. If you are working with more complex geometry where you have a lot of different surfaces coming together, the shell command will most likely fail. Okay, so that is where you use offset surface command. Again, where you can also, of course, offset a surface and make it solid as well. So it's going to do a similar thing, the end result, which is going to give you a thick body part, but the shell command is the simpler version of it. The offset gives you more control and generally recommended for complex surface and poly surface.
Right. Thank you so much. We go to the next one. It says, what is a little bit long. What option tools are in place to facilitate the propagation of a requested change in the root form without requiring a complete reconstruction of every step and all downstream parts, accessories, components, etc. in the build process? Are the use of history or Grasshopper the only or recommended workflow? An excellent tutorial. Thank you.
Amazing. Thank you very much. So you are halfly answering your own question. Yes, Rhino has a record history and it has Grasshopper. They both have their record history has its very limited advantage, but you can never create a full-fledged parametric model like the way you can do in Fusion, SolidWorks, CATIA, etc. Rhino is a direct free-form modeling tool. Direct means everything is happening in real time. There is no past, there is no future, there's no timeline, there is no data hierarchy, okay? Which also gives it a bit of advantage because you can treat Grasshopper as an open playground, like the way you see here. And the way I resolve it is by having a physical timeline that you see on the screen. And this is not something I prepared for only this exercise, but if you check any of our webinars or any learning resources, you can see we create the model in a very similar manner, where we have literally a physical timeline of the steps. So yes, it's not a full-fledged parametric tool where, let's say if you have to modify something here, every other steps will be taken care of, but it does save you a lot of time in the long run. So let me give you an example. Let's say here, if I mess up somewhere, yes, I can do Control-Z and go back a couple of steps. But imagine I saved the file, I closed the file. So you cannot do Control-Z after closing the file, okay? So I can at least go 2-3 steps back and recover the geometry and start from there rather than trying to resolve the mess that I already made. The other problem in this case would be, let's say you're trying to modify something from the front face, which was made probably in the second and third step. And I agree, that's going to be a very long set of steps that you have to redo. But imagine you still have other parts in your model, which you have modeled. Okay, so in this case, I can at least use these extra geometries and I don't need to remodel them from scratch. Okay, it's not a short technique, but I have found this technique very useful in professional projects. It has saved me a lot of time. I also create like versions of models in this manner so that anytime I open it, I know how it was made. I can trace back any issues that I have. So in the long run, this is very helpful. The only downside is it can kind of like bulk up the size of the file. But there is a command in Rhino called clear all meshes, which is literally what happens when you run save small. save small. So when you run clear all meshes, what it does is it clears the mesh cache, which helps you reduce the file size drastically. So that's your way to create a compact file. Next question.
So I have an error code that says you noted a tolerance part at the parting surface. Was it the part discarded, leaving a gap between the matting parts, or did the parts touch in the end, leaving only a shadow gap line at the exterior surface?
No, they had a literally gap between the two sides. So if I show you in rendered mode, you can see the gap. Okay. The gap is probably 0.5 millimeter, but everything in the computer screen looks huge. But trust me, this is a common issue. Whenever you face with that issue, like how this model is going to look in real life, I always do this. I go to set view and then use the zoom 1:1. Probably something is wrong with the scaling of my screen. But yeah, it's probably, yeah, I have to recalibrate it somehow. Anyways, like you can measure literally the length of this bar, and then that is gonna tell you. So this is not 12.7 as I'm looking in my screen. This is most probably 17 to 18 centimeter, like 180 millimeters. When I press OK, then I can see a real scale model on my screen. Okay, I don't know if you knew about this feature, but it's a very useful feature in Rhino. You right click, measure that blue bar on your screen, and you have a real scale of the product on your screen. All right, questions?
An amazing tip. I have Eduardo, when modifying the surface made from network of curves made on step 9 and 10, is there a way to modify and adjust the control points from the surface in a way the gumball is aligned to the cross-section curve, or in some way it is not fixed to the 90 degrees default scaling of the gumball?
Sure. So yeah, there are very good documentation resources you can find for gumball manipulation on the Macnil website. There are tons of ways you can do the same thing. So the first is select the points, and then you turn on the gumball. Okay, if new joiners who have not used Rhino, you can click on this tool, which will turn on the gumball and turn it off. You can click on the white circle here, and then you can align the gumball to object, to view, to world. Okay, you can choose one of these options. Apart from that, let's say you want to move this point along the UV and W, so the UV and the W direction. There is a command called move UVN. Okay, move UVN. And this is a tool that will help you move the control points. Select the point, and you can move it along tangent, along the control polygon, or along the extension of the control polygon. Let's say along control polygon. I'm going to move it in the U direction, that is the red direction. Can you see that? It's moving in the red line. Quick tip, if you want to remember what is U, what is V. V is for vegan, vegetarian, so green colors in these arrows is always V direction. And then you can use the V to move it up or down. All right. So you can use these different options to move the points, either using gumball or using move UVN tool. All right, next question.
Nikolai asked if you could explain the drafting analysis command a little further. This would be amazing.
Sure.
And if...
Yeah, so just you can go to the, I think one of these options. I think it's the just next to the button, the shell one, or last of the button, and use that model as a test and run analysis, draft angle analysis. Okay, this tells you if you are going to prepare this geometry for injection mold, which part of the design can be easily demolded, which part, the green part might leave scratch marks, but the red parts, as we have overhang, they cannot be demolded. Okay. So imagine if this part, let me rotate it by 55. Okay. If this part is made like this. So until the green part, we can demold the top geometry easily. Okay. Everything apart from there, in the same mold, we cannot demold it. So that is going to give you a good idea where we should break the part. So the green above should be one piece. You can repeat the process by rotating it and or changing the vector and doing it for the other side. That is going to give you a section where you can like part the geometry in two pieces. This should actually be done in the very first step when you're calibrating the surface. Okay, so that you have more control. Because once we have started working on the geometry as a solid model, modifying the shape of the surface is impossible. Like you have to go very back. Okay, so do this step at the very beginning. All right, more questions?
I have Arnaud. How do you change color of interior surfaces? Looks very useful.
Sorry?
So how do you change the interior color of surfaces?
Yeah, you can go to document properties. Then view display mode, we are changing the shaded mode. And here you have different options. So in shading settings, you can change the color of back face. Okay.
So I have two more questions. One is from Ujwal. Which offered course goes more into DFM commands of Rhino, like draft angle analysis, command you use in this demo?
Sorry, can you repeat?
Yes, which offered course from Academy, I guess, goes more into the DFM commands of Rhino, draft angle analysis.
In two of our courses, we go through these tools. One is our Rhino Masterclass, which is going to take you from the very beginning, like the basics, solid modeling. Then we will learn the foundation of NURBS, curves, and surface. What is degree, span, continuity? And then later on, we will slowly gain more experience. And in one of those examples, we learn how can you find the draft angle analysis, how can you find the parting line, how to clean the parting line, break it, create the solid model, what is loose offset, what is tolerance-based offsets. So those things will be covered in the Rhino Masterclass. Later on, you will also learn how to create simple examples of Class A model. You can see the difference between the quality of highlights on a model made maybe in 30 to 40 seconds and a model that can take a couple of hours, but which is ideal for manufacturing. Maybe this is ideal for ideation. Now, apart from that, another course where you can learn these tools is in our advanced parametric texture workshop, because these are textures that are made in the NURBS context. And we will see how can you manufacture these textures. For example, if you have to manufacture this texture, the perforation, you cannot just have the perforations normal to the poly surface, because imagine the complexity of the mold to demold that part. So in this case, we will be aligning the vectors to, let's say, 8 possible vectors so that you can demold the part easily. Okay, so we will use these examples to learn design for manufacturing. One is going to be in the Rhino model, and this one is going to be in Grasshopper textures. Okay, but yeah, the goal of all of our tools that we show here is at the end of the day for manufacturing and industrial design. So we always keep in mind those criteria. Right. Any last question?
Yes, from Ko again, do you recommend V-Ray or Keyshot? I would recommend Rhino directly, but I know.
Yeah, sure. Again, like it totally depends upon what are you used to, what's your budget, what is your pipeline, what is your company using, what kind of contracts they have. But if you are just asking me for the easiness of use, I'm going to be frank, I use Keyshot. it saves me time. It's very expensive, to be honest. Rhino costs $1,000, like around more or less, for lifetime license. Keyshot is $1,200 for 1 year. So you have to, but the price can change when you see the webinar in future. So don't take my words for it. See what's the price, compare. You can download trial version of everything, give it a shot, and see which is you're best comfortable with. That is the right software.
Thank you. I agree. Okay, so I closed the questions. There's some that I could not answer, but there are technical issues that you can contact us at McNeil. We have a free tech support for any users. So in rhino3d.com, and I will send the links. You can send us your file, or any question that you have for the courses that Academy gives. You can contact them directly to see if they're advanced, if they're for beginners. But we will send you an email with all the information. Don't worry about it. Thank you so much, Aman. Thank you so much, everyone, for participating. I hope you had a good time. I did. So I'll see you next time.
Thanks. Yeah, thank you all for joining, and let us know if we can be of any help. And I see some familiar faces, so shout out to you guys for joining again, and hope to see you in one of our live classes. And Agustina, thanks for organizing everything, and good luck to you guys as well.
Bye.
Perfect. Thank you. Take care, guys. Bye.